Okay, question 3. Here you're allowed to use your calculator. Okay, so it says Mr. Scrooge. I'm not going to write out the whole question. Mr. Scrooge invests 15,000 rand. Okay, at 12% per annum compounded quarterly. Okay, if you compound it quarterly, immediately, how many times do you get it in a year? 4 times. 4 times, that's important. At the end, he receives, okay, he receives 27,091,67. For how many years did he invest it? Okay, what formula are we going to use for this question? Yeah, the normal compound formula. Excellent. He just invests it once, gets the money back in the end. Excellent. 1 plus I to the power of n. Okay, which values are going to go where? Yeah? 27,091, what is that? 67. P 15,000 for I.
That's 0.12
over 4. I usually write it like that. Same thing, yours is not wrong. I like to write it like that. Okay, so it's the 12 divided by 100, but it's also divided by 4 because I get it 4 times. And then the n will just leave as n. Okay, what does n represent? Okay, it's the number of times he gets interest. Okay, we get interest 4 times a year. Just keep that in mind. Your answer in the end is not your final answer. I'm going to work out now, I'm working out the number of times he gets interest. They are asking how many years does he invest the money. Okay, so we'll see now when we get to the answer why I mean. So how will we simplify this? You divide 15 on both sides. And don't get the answer. Don't divide it. Just get it away this side. Okay? Then once we have it like that, what do? So now we have a base exponent equal to an answer. Log. So n is equal to log. What are we going to use for the log's base? This amount, whatever you get. You can simplify it in your calculator if you want, or you can just, when you type it into your calculator, most calculators can choose any base. Okay, and then the value here would be that 27,000, sorry, not the comma there, 27,091,67 over 15. So you see, I don't even need to use, I just use my calculator for my final answer. Okay, so what do you get in that if you do that calculation? Exactly. Okay, so we get exactly 20. So for how many years did he invest the money? Excellent. So this is for 24 periods, or whatever you want to call it. Okay, he gets it 4 times. So if we divide this by 4, that's how many years we get, because this is already multiplied by 4. Therefore 5 years. Excellent. Just, as we say in Afrikaans, hou net kop. Just keep track of what you're doing. 3.2. In 4 years' time, Daisy would like to have 200,000 available to buy a new car. So in 2 years, in 2 years, Daisy wants 200,000 to buy a car. Calculate the amount she must deposit monthly into the account if the interest rate is 8% compounded, 8% per annum compounded monthly. Which, sorry? Oh, sorry, thank you. In 4 years' time, she wants 200,000. Which formula will we use this time? Good, because she wants in the future 200,000. So there you go. You already get marked just for choosing the correct formula. Hopefully you know it off by heart as well. And now what will we put in for F? 200,000 is put in for F, and X? We don't. That's what we want to calculate. We want to know how much money should she deposit monthly into the account. So that's the X. Okay, we have the interest. Please keep track that your interest must be 8 over compounded monthly is 1200 to the power of 12 times 4. She will deposit every month. So remember, N is how many deposits she will make. And if she does it over 4 years and she does 12 deposits a year, it would be 48 deposits in total. Minus 1 over 8 over 1200. Okay, same thing applies. We just want to solve for X. So we're going to multiply both sides with an 8 over 1200. So this thing is going to be multiplied with 8 divided by 1200. And we're also going to divide both sides with this whole bracket. So divide this side with 1 plus 8 over 1200 to the power of 48 minus 1. That whole thing is going to divide this side as well. So 1 plus 8 over 1200 to the power of 48 minus 1. Can you see there? It's a bit small, but you can see what I'm doing. Okay, that will cancel this whole thing. That whole thing, so I'm left with X. So what is that X value? Just punch that into a calculator for me. So it's 3049, comma 2511. Okay, so 25 if we round it down. Okay, well, round it to the nearest. Good. That's how much she must deposit every month for 4 years so that she has 200,000 in N. Okay. Last question in this section, question 3.3. Donald takes out a loan of 8,000 Rand from the bank to buy a new computer. Okay, the interest rate is 10% per annum, compounded monthly. He decides to pay installments of 750 Rand. Okay, so he takes out a loan of 8,000. 8,000 loan. He pays it back with a payment of 750 Rand per month, and the interest is 10% per month compounded, per annum compounded monthly. Okay, which formula this time? The moment someone pays installments monthly, it's annuity. The moment there's monthly, now it's just a question, is it present value or future value?
Present value.
It's present value because we get a loan now. You don't get the 8,000 Rand in the future. It is the value that he gets right now to buy this computer. So P is equal to X 1 minus 1 plus I to the power of negative N over I. Good. What do we put in for P? P is the value of the loan. He pays it back, 750 Rand per month. 1 minus 1 plus 10% is 10 over 1200 because it's per month to the power of negative N over, and again 10 over 1200. Again, I'm just going to have to solve this because they ask us calculate the number of installments. N is the number of installments. How many times will he pay? So eventually we want to get that N on its own. We multiply therefore everything out. We get this times that gives me 10 to the 10 times 8,000 divided by 1200. See, there's the 10 over 1200 times the 8,000, and then this side we divide the 750, so the 750 becomes part of the denominator, 750. Now we're just left with the bracket, the top, what's inside the bracket. We got rid of what's outside. Inside the bracket there's a plus 1, so when we subtract it on the other side there's a negative 1. But now there's still a negative in front of this bracket. See, I'm trying to get this bracket with the N all on its own, but there's still a negative. So I'm going to take that negative and divide it on this side, which just changes this positive into a negative, and it changes that negative into a positive. So a different way that you could have wrote it is you could have just said this becomes 1 minus that, because the 1 becomes, that used to be negative, becomes positive. And then now this is now what I have. I've got this bracket 1 plus 10 to the power of that is equal to that. Now you'll notice I don't use a calculator yet, because if I use the calculator anywhere up to this point I'm going to make rounding errors. I only use calculator in my very final answer. And then I get students to do it for me. Okay, so we get now, use our logs. Negative N is, that's our exponent, is equal to log of the base. Again, you see I don't calculate the base. I'm going to put it in like this into my calculator. Then I don't have to work with decimals. Okay, and so please give me the answer. You'll get a negative answer anyways, and then what's that? 217 goes on. Okay, so how many payments will it take for him before his loan is paid off? Okay, why is it not 11? If he makes 11 payments, would he have finished paying his? No, because if the answer was 11, it would have been 11. It's 11 and a little bit, which means after he's made 11 payments, he still has a little bit of payments left. Okay, so again, okay, think of your answer. Is it 11? But we don't just always round to the nearest whole number. It must make sense, that number. Okay, so 11 payments is not the right answer. Yes, it is the right answer if we round it. But we're not trying to round, we're trying to answer their question. And do you understand why it's 12? Makes sense. There's still a little bit. It's not a full payment, but there is another installment, so there will be 12 installments. What will be the amount of the final installment? Now this is a standard way that you can go and calculate the final installment, because it's often that you will have an answer like, can you see the final amount won't be 700, he's paying every month 750. Okay, the final installment is not a whole payment, it's only like 0.217. Do you understand? So here's how you would do it. You'd first have to work out how much money does he have, how much money does he owe them after he's paid 11 installments. Does that make sense? So let's see, how would we work that out? Remember, whenever we want to work out the balance, that's what we call the balance, we use this formula. This is basically the balance formula when I have made n payments. So you'll see if n is equal to 0, if I haven't made any payments, then if that is 0, this whole thing is something to the power of 0, which is 1. 1 minus 1 is 0. Okay, 0 times anything. No, sorry, I lied. Sorry, forgive me. It's if n is not how many payments I've made, it's how many payments I have left. Okay, so if I have all my payments left, I'll owe them P. So if there's 20 payments left, I'll owe them whatever amount is still there. But if I have no payments left, if n is 0, then this whole expression becomes 0, so I don't owe them anything. Do you see? So this is what, so how many payments do I have left? Yeah, so I want to work now out. Sorry, I've got one full payment left. No? Yeah, you're exactly right. It's that I've made 11 payments. Okay? So whatever is left here is, so after I've made 11 payments, whatever comma is left there, that's the portion that I still owe them. So that's exactly what I put in. So I want to know how much do I still owe them. I'm paying them 750 a month. What is still in the bank? After negative 0.217, and you will use that whole value that you have there. So in your calculator, just subtract 11 from that value and then store that value so that you can use it later. Okay, and that's what you'll substitute in there, divided by 10 over 1200. Okay, what answer do you get? Yeah. So what answer do you get? 162.176. Excellent. And this value goes on. Don't round off yet. This is how much I owe them that the moment I made my 11th payment. Okay.
What another simple way? This is 750 times 0.217.
They're not the same amount. It's not the same amount.
I mean, except for the decimals.
Yeah, but it's not the same amount. It's close. But if we were working with bigger numbers, if this was the 750,000 monthly installment, for example, do you understand? So it's not the same. It's not a simpler method. It's wrong. Okay, what you're doing is you're working out a percentage of the payment, and that's not what it is. Okay, what we have to do now with this value, this is the value I owe them a month before my 12th payment. So this one, I must still go and add 1 month's payment. 1 month's interest. So this will be the formula if I wanted to work out what is my last installment. You'll always have to take that little bit in the end, put it in, and then you'll always have to add 1 more month's interest, because I know how much I owed them at the end of last month. I just owed them a little bit more, but now by the time I get to the end of the month and I have to pay them, there was interest. Make sense? Okay, so just 1 month's interest, which is 1 plus 10 over 1200 to the power of 1, because it's just 1 month. So just that number times 1 plus 10 to the power of 1200. And what is that final answer? Excellent. Now we can round off. Does it make sense how you would calculate it? Makes very much sense. That's not a difficult way of asking it.